Hello, everyone, and welcome in this practical section number two of our chapter about sustainable packaging and product innovation. In this section, we will talk about different parts of the chapter regarding exercise with real companies example, real technologies, real regulation, professional software tools used in packaging and food industry. So learners are required to analyze consider data, understand innovation drivers, and identify success and failure factors, and extract best practice that can be transferred to other contexts. The exercise respect the origin course, structure, plan, and progressively move from packaging fundamentals innovation, digital tools innovation, impact of environment, circular business model, and value addition of packaging sustainability. So let's move for the first exercise number one. It's about eco-design practice with one of the celebrated companies such as Danone Yogurt Cup Design. Danone has implemented several eco-design strategies for yogurt packaging in Europe, but also for different product of this milk product industry, and including lightweighting, the use of recycled PET polyethylene, polyethylene triphthalate, rPET, elimination of unnecessary pigment, and improved recyclability throughout monomaterial design. This change aims to reduce environmental impact while we maintain food safety, consumer acceptance, compliance with regulation, and improve quality of the product. So, task for learners is about analyze Danone's redesigned yogurt cup and compare it with the conventional private label yogurt cup style using heavier or less recyclable materials, identify which eco-design principles are applied and why they are considered best practice. For that, we will use this table with the different criteria and applied for Danone yogurt cup and conventional yogurt cup with interpretation based on this comparison, used this criteria regarding main material, packaging weight, recycled content, monomaterial design, recyclability and practice, consumer sustainability messaging. And as a reference, we are indicated this link, and learners are invited to consult this website to more information about impacts of the packaging and the trend and the creation design of Danone company. For that, we invite learners to answer the question about which eco-design principles are clearly applied in Danone's packaging. How does lightweighting reduce environmental impact? Why is monomaterial design considered best practice? What technical economic trade-offs may result from the choices? How does Danone communicate sustainability to consumers? And finally, which practice could realistic be adopted by smaller dairy producer with comparison of this type of packaging? Let's move up for exercise number two. It's about reducing environmental impact of bottled water, and a strategy adopted with another celebrated company such as Nestle. Nestle Waters has committed to making all its packaging recyclable or reusable and increasing recycled content in polyethylene terephthalate innovation focus on bottle lightweighting and RPT, recycled polyethylene terephthalate, integration and design for recycling principles. So learners are invited to compare a standard PET water bottle with Nestle Waters and RPET bottle and assess how design innovation reduce environmental impact and complete this table regarding virgin plastic content, recycled content, bottle weight, estimated carbon dioxide reduction, and recycling compatibility. For that, we are integrated this web link for more information about the strategy of water, of Nestle water, and more data. For that, we have this question, which innovation provides the greatest environmental benefit? Why is RPET considered a transitional but not final solution? What regulatory constraints exist for food contract recyclable plastics? How does bottle design influences actual recycling rates? And finally, can this innovation model be applied equally in all countries based on even for data of this exercise, but also with analysis and review of our course about innovation packaging. Let's move for exercise number 3 about when sustainability packaging fails with these compostable plastics as a case. Several compostable packaging solutions are used, but are limited as for their use. Limited regarding environmental benefit due of insufficiency industry composting infrastructure, consumer confusion, and improper waste sorting. For that, the objective of this exercise is to analyze why compostable packaging solution may fail despite good environmental intention. For that, we have this table about failure analysis of compostable packaging with different dimension, end of life treatment, consumer behavior, waste infrastructure, environmental impact, regulatory alignment. The objective is to analyze different benefit and outcome for this type of packaging fails, and then give solution and with answering different question. First question, why does compostability depend strongly on local infrastructure? How does consumer behavior influence sustainability outcomes? Why can recyclable materials outperform compostable ones? What role should regulation play in approving compostable packaging? What mistakes did companies make in this case? And what best practice can prevent similar failures? That is an analysis exercise for data, but also with visiting this website for as a case study. Let's move to exercise number 4 regarding regulation as an innovation driver for Europe EPR and eco-modulation. EPR is extended producer responsibility. It seems in Europe and increasingly apply in eco-modulation companies pay higher fees for poor recycled packaging and lower fees for sustainable design. For that, learners are invited to analyze how EPR regimes influences packaging innovation design with answering this different question and complete this table regarding feature for packaging, lightweighting, recycled content, label removably, color and pigmentation for different type of modulation, eco modulation design. For that, we have integrated also in a figure, as we can see in this picture, with different waste information and eco modulation of EPR fees with different information with different type of waste. For that, learners are asked to answer different questions. Why is regulation a powerful driver innovation? How does every year change cost structure for companies? Can eco-modulation accelerate eco-design option? What risk exists for companies that in your API scenarios? Is this regulatory model transferable outside Europe? Let's move for exercise number 5 regarding material selection using for real market decision matrix. As case, we choose a cheese packaging. A cheese producer use different packaging solution depending on shelf life, on quality, on cost, and sustainability target. Common options include PET packs, paper-based laminates, and bio-based multi-layers. So the objective of this exercise is the use and analyze these different materials and use a weighted decision matrix to identify the most balanced packaging solution. For that, we invite students and learners to complete this table with different criteria: barrier, performance, recyclability, carbon footprint, cost, and total score for each one of these criteria with different variables such as PET vacuum, paper laminate, and bio-based multi-layer. With this reference as for more information about a package and information in Europe. First question, which packaging options score highest overall after comparison? Which criterion must influence the final decision? Why are paper laminates often controversial? How does food safety limit material innovation? Would the result change for export market? What best practice emerges from this analysis? Regarding the exercise number 6, we talk about a new tool and as a software tool for life cycle assessment software in packaging named SEMA-Pro, one of the advanced application in packaging area for the industry. SEMA-Pro is one of the most widely used professional LCE software tools in packaging consistency, eco-design department, and certification studies. Many advantage for this use that we are used also on our laboratory to analyze different data regarding quality of food in relation to nature of the packaging. Companies so is used and to justify material choices, support regulatory dossiers, and compare innovation scenarios. As case scenario, we choose this company to that are interested to redesign 500 milliliter beverage bottle. Two alternatives are under evaluation. Two options. Option one is a virgin PET bottle, and option two is 50% rPET bottle, which with lightweighting. For that, students are invited to explain how SEMA-Pro would be used to model and compare the two scenarios and interpret the result. As you can see in this table, we have the result for different options regarding bottle weight, virgin PET, recycled PET, electricity mix, and end of life of one of this type of scenarios. Expected impact are also provided regarding climate changes, fossil resource depletion, water use, and water generation, and more information regarding the software and this website with this link. Learners are invited to consult this website for more information on this new advanced tool. This software are used with researchers and with the PhD, with the professional to analyze, to models, to create the model for quality of the food regarding the quality of the packaging. As we can see in this example extract of this study. As you have a link directly of the study. A result of characteristic of LCA for intelligent and connected packaging and similar software that provide multi-information regarding composition of your packaging, mineral resource, fossil resource, climatic changes, impact of this composition, organic resource, and all this information are integrated as data and this software and give more information and interpret that allow to analyze and give solution for some problematic industry problematic related to packaging and quality in general of product. So for that first question, which life cycle stage contribute most to total emissions? How does lightweighting influence multiple impact categories? Then why does recycled content reduce fossil resource use? What assumptions must influence the final result? How can companies measure LCA results? And why is CIMAPRO considered a decision support tool rather than decision marker? Let's move for exercise number 7 about open life cycle assessment and SME level sustainability assessment. Many SME companies cannot afford communicate commercial LCA software, so there is an alternative such as Open LCA for all that we can use directly, combined with free database allows SME to conduct simplified sustainability assessment and guide eco-design decision. For that, a small food processor wants to compare cardboard boxes with plastic crate for product transport. And objective of this exercise is to describe to analysis how Open LCA can be used to perform simplified comparison and identify its strengths in imitation. As you can see in this table, we have integrated different information for this regarding the mass, reuse, recycling, transport distance for different type of this materials, cardboard box, and plastic crate. As you can see in this link, we have more information regarding this tool that are very professional and easy to use with for some SME level. For question, why does reuse significantly changes environmental performance? And then which assumptions are critical in simplified LCAs? What risks exist when using database? How sustainable is Open LCA for regulatory reporting? How can SMEs avoid misinterpretation results? When should an SME outsource fail for LCA study? This is all for this exercise. Let's move for exercise number 8. It's about MEP, modified atmosphere packaging, one of the used tool in industry for shelf life, for quality, and for storage of product, food and beverage and other products. MEP is a mature but continuously evolving technology used extended shelf life or fresh food. Recent innovation focus on optimize gas mixture and thinning barrier films to reduce material use. A retailer compares fresh poultry packaged with conventional packaging versus MEP. That is the objective of our exercise. So learners are invited to analyze this information, this table regarding different indicator, shelf life, retail loss, packaging materials, annual sales volume for convention and MEP packagings. About technology provided, we have this link and integrated this link for more information. And the objective is to analyze whether the additional packaging materials is justified by food loss reduction, and how food waste is avoided annually using MEP. How do how do food waste emissions compare to packaging emissions? Which products benefit most from modified atmospheric packaging, and how can MEP be combined with recyclable materials? What consumer concerns may arise? What best practice should guide MEP implementation? One of the practical exercise and the tools that used and the tool used largely in industry of food of and vegetables to to conservation of the quality, but also extend the shelf life of this type of product. Let's move for the exercise number 9. It's about smart packaging and digital sensors. One also of the uh, new tools about data-driven waste reduction as used as a tool for information of the product to analyze different to analyze data about smart packaging, for example, or other tools of other materials for packaging. In general, smart packaging use sensors and indicators to provide real-time information on product freshness, temperature abuse, or remaining shelf life. Between 2023 and 2024, costs have just decreased and pilot projects have expanded in meat and seafood sectors. The objective is to analyze different sectors for this type of product and give an analysis and a great analysis for this type of sector using this type of new technologies and packaging area such as smart packaging and digital sensors. As you can see in this table, we have smart packaging performance for the different tools for we analyzes different time temperature indicators on fresh fish packers. As you can see in this table, a various shelf life, distribution loss, added packaging, cost, and consumer complaints. For that, we have also integrated this link for more information about this new tools used in the packaging area. About question, how does real-time information reduce waste? How can dynamic shelf life change logistics? Are added costs justified economically? What data management challenges exist? How do smart level affect consumer trust? What future development are expected in smart packaging? One of the a new trend of for industry and used with to improve quality and control of and management of food quality, not only in an area of food agri-food, but also in different areas such as cosmetic, pharmaceutic products. That is all for the exercise number 9. Let's move for exercise number 10. It's about industrial symbiosis using packaging materials from agriculture residues. Uh, about professional context, objective is analyze industrial symbiosis enables byproduct from agricultural food processing, bagasse, husks, straw, to become raw materials for packaging, reduce and virgin resource extraction. For that, a sugar mill suppliers bagasse to a packaging product manufacturing models fiber trays. And for that, we have this table as a resource flow analysis with different parameters and value for each one. For example, bagasse generated ton per year, packaging output, virgin pulp avoided, and carbon dioxide reduction with different value for each parameters. We are integrate this link as reference for more information about circular bioeconomic uh, bioeconomic related to industrial symbiosis. For a question, we have the first question about industrial symbiosis. How does industrial symbiosis reduce environmental impacts? What logistical constraints exist? How does quality variability affect packaging performance? Are food contact regulations a barrier? How scalable is this model regionally? What best practice ensure long-term viability with analysis of the information in this exercise table, but also review the course because we have a part about industrial symbiosis with more information that make easy understand this exercise and give answer to different question. Let's move for the exercise number 11 about circular business model analysis with another tool, technological tool such as Loop reusable packaging system. Loop operates reusable packaging systems in partnership with major brands. The model shifts sustainability focus from materials to systems and logistics. As a scenario, we will analyze and compare single-use packaging with loops, reusable containers over multiple cycles with different indicators such as use cycles, packaging waste, logistics complexity, consumer engagement required. With different single-use such as some single-use packaging, loop reusable systems for any and indicator for each indicator in this table. We have indicated this reference for most information about Loop Store with information about this tool, this best tool, and that's one of the strand and of this type of packaging and circular business. As you can see, at what number reuse cycle does Loop become environmental favorable? For the question, how does the reverse logistic affect emissions? What role does consumer behavior play? Which products are best suited for reuse? What economic risks exist for brands? And finally, what best practice supports scalability? For that, we have integrated this picture regarding different phases for use of water and packaging with these tools as a loop model for analysis the process step by step from initial from commercial to finish the packaging product. Let's move for the exercise number 12 to last exercise about value addition and market differentiation. One of the part of our course, best clear part and interested part of the course about sustainable packaging, about premium olive oil packaging as case for this exercise. In premier food market, sustainable packaging contribute to storytelling, brand identify, and willingness to pay. Olive oil is a strong example due to origin, quality, perception, importance of packaging regarding the composition of the oil and bioactive compound. So the management of the packaging of the one of the best question for this industry and also for the export orientation. A premier olive oil producer compares standard PET bottle with eco-design glasses bottle and refilled systems. As you can see in this table with more information about different criteria, packaging cost, perceived quality, sustainability perception, export market acceptance for standard PET bottle and eco-design glasses. As you can see, eco-design glasses have high quality, high information, high result comparison with standard polyethylene flat bottle, as you can for different criteria regarding packaging cost it's very high, but for quality it's very important to use eco-design glass and profile packaging tape. About reference, we have indicated this reference for an international uh, uh, olive oil with more information about this area of agri-food sector. For question, we have integrated this question for the first question. How does packaging influence perceived value? Which sustainability claims are most credible? How does design affect willingness to pay? What risks of greenwashing exist? How does profile improve sustainability? Can higher packaging costs be economically justified? What best practice are transferable to local producer? For that, we have indicated also this graph regarding global olive oil market with this proof and increase between 2024 and 2032 with high evolution of this food product and market. For that, it is very important to choose the materials for packaging of this type of product to management quality, preserve sensory quality, preserve nutritional quality, and also to complain about regarding compliance for regulatory, for local regulatory, but also for export market and international regulatory. That is all for this part of exercise of section of practical section for regarding packaging, sustainable packaging innovation technology. And thank you for your presence for this section.